So the book asks you about domain and range, and rather than talk about it like in the context of sine and cosine, we probably should like back up and think about domain and range like
as words.
Like what do they mean in terms of vocabulary? So I've actually glossed over in what I've written here the real vocabulary word that you need to know, and that's function. But we'll hit pause on that and just say, let's say we want to do something in the world.
Okay.
The domain of that thing is what we are allowed to put in to the situation. And the range is what it is possible to get out of the situation. Okay? So think about this. What if I have a black and white copier? So I don't know what they look like, but there it is. Okay.
Those are really interesting black and white copiers.
There. So the domain might be...
It could be anything.
Really? You can put a turtle into a black and white copier? So the domain would be 8.5 by 11
It could be smaller.
sheets of paper.
Or smaller.
Right. Or smaller, right. Let's say size less than or equal to, right? And then the range will be, in this case, if I load it with 8.5 by 11 sheets of paper, the range will always be 8.5 by 11 black and
white paper.
Right.
No, you should not stick animals into photocopiers.
Right. So this is just like an abstract example of domain and range. Okay, let's think about sine. Okay, now instead of having a copy machine, I have a sine machine.
Okay then.
Okay. The domain. What am I allowed to input into the sine machine? What goes here?
Anything.
Anything? I can put a turtle there.
If it fits.
So,
Any number.
Any number. And why is it that... So, conceptually, the domain of sine...
All real numbers.
They're angles. Right? Angles. And it just so happens that for any real number, I get an angle. Okay? So, the domain of sine consists of angles, right? Mm-hmm. And any real number, because any real number defines an angle. Right? But if I say, what is sine of 720 degrees, I know because I'm using the convention of angles that whatever the answer it is, it ought to be the same as sine of 360, which ought to be the same as sine of 0. Even if I don't know what the answer is, I know that these all have to be the same because these real numbers that I'm putting into the sine function, I'm thinking about as angles. Okay?
That's a bit easier to see.
Okay. So now, what is the range?
The range is an angle.
You sure? So what part of the unit circle? So what part of the unit circle does sine report? So I'm gonna draw.
All of it.
So I'm gonna draw a point right here. Okay, and let's zoom on in. And we know this point invokes the notion of a right triangle, right? And we've decided this is our angle, okay? And so we've plugged this angle into sine, and we've gotten sine of theta. In this picture, what geometric measurement represents sine of theta? It's the y-coordinate, right? So this thick green, maybe I won't even use green here, I'll use blue.
Okay.
This vertical blue line, the length of that line is sine of theta. Okay? In other words, the output of sine of theta is the y-coordinate of the point on the unit circle. Okay? So like, for example, how do I figure out what sine of pi over 2 is? Do you remember what degrees pi over 2 was?
What?
If pi is 180, then pi over 2 is 90 degrees. Okay, so how do I figure out what sine of pi over 2 is? Well, I go to the unit circle and I say, what's an angle of pi over 2? Well, an angle of pi over 2 is this. That's 90 degrees, right? And so I say, okay, the point on the unit circle that corresponds to 90 degrees is right there. Okay? Because that angle right there is 90 degrees. Okay, what are the x and y coordinate of that point? What's the x coordinate?
What would be the x coordinate of this point?
So I'll turn it so you can see.
0.
And what's the y coordinate?
1.
1. Now,
So
if
you'd read it like an xy graph?
Exactly.
Okay.
Okay.
I was thinking some weird fraction.
And that tells us that because by definition sine is the y coordinate, then sine of pi over 2 is 1. Okay? What if I then said, all right, tell me what sine of 3 pi over 2 is? Well, we can do the same thing. And I'll do a little trick. I'll show you a little trick about 3 pi over 2. If this distance right here is pi over 2, well, this is 1 pi over 2. This is 2 pi over 2. 2 pi over 2. And then finally, this bottom here is 3 pi over 2. So I'm thinking of this as 3 times 90 degrees. Okay?
Okay.
So 3 pi over 2 is 3/4 of the way around the circle. It's a strange angle, right? But if you think about it in terms of distance around the unit circle, it's no big deal. But now we can use our recipe for the function sine to read off sine of 3 pi over 2, and it's going to be -1. Because that is the, -1 is the y-coordinate of that point. Okay? So, this whole illustration was to point out what the range of the sine function is. Okay? The range of the sine function is the y-coordinates
Output.
of the unit circle. Okay, as numbers, what can we say about those numbers as real numbers? So if angles can be any real number in the world, the y-coordinates of the unit circle can be what? Can it be 2? What's the biggest y coordinate? The biggest y coordinate is here.
Okay.
And the smallest y coordinate
It's
is there.
-1.
Right. And it can be anything in between.
Okay.
All right. So -1, 1, and anything in between. Okay? So, finally, let's sum it all up. The domain of sine, and I'm leaving it open, thinking of this as like a copy machine. The domain of sine consists of all angles, numerically all real numbers. Okay? And the range consists of y values on the unit circle and numerically, of course, I would write it like this. Have you ever seen this interval notation?
Not really.
Okay, so I'm gonna close with this kind of notation. If I draw a number line and I put a colored in dot at -1 and a colored in dot at 1, and I shade everything in between, okay, these are like the x's that are less than or equal to 1 or bigger than or equal to -1.
Yes.
And I write that with these square brackets. Okay? I could do this. I could say, let's poke a hole at those spots.
Let's poke a hole. And that would be without the equal sign.
Exactly. And the way I write it as a set is I would write this. Okay? And then you can do combinations where, you know, I have a closed, this is called closed,
And open.
and this is called open.
That would be a...
Okay, so this would be like x less than 1,
And
bigger
that's
than or equal to
bigger.
-1. Okay, and then I'd write it like this. This is just notation, and you're going to see it in the book quite a bit, probably.
Okay.
I don't know. But so that's notation, and the reason why we have this notation now is it's the most effective way to write the range of sine.
Okay.
Okay? So conceptually, for any mathematical thing in the world, the domain is the allowable inputs, and the range is the possible outputs. For sine, the domain is angles, which means all real numbers.
Okay.
And the range is y-coordinates, which means y-coordinates of the unit circle, which means this set. Okay?
Okay.
All right.